This video is about proof by induction. Proof by induction is a really useful way of proving things about the natural numbers. Let's start with an example to see how it works. If we look at the first few natural numbers and add them together, it's easy to work out what we get. And if we stare at the answers, we might start to see a pattern. And after a while, we can see that if we add together the first few natural numbers, we get something that's quite predictable. So by looking at these answers, we might be able to guess a formula for the sum of the first n natural numbers. It looks like the sum of the first n natural numbers is a half of n times n plus 1. Now at the moment we've just seen 5 examples of that, and we don't know whether that's true in general. So in this video we're going to use proof by induction to show that the sum of the first n natural numbers is a half n plus 1. To use proof by induction, we're going to write down the statement that we're trying to prove. Here it is. And we're going to call that statement P of n. So P of n is not one of these formulas. P of n is this statement that the sum of the first n natural numbers is a half n plus 1. And we're going to try to prove that P of n is true for all n greater than or equal to 1. And the way we're going to do it is this, using proof by induction. And for proof by induction there are 2 stages. The first stage is called the anchor step, and we try to prove that P of n is true for some starting value. And here that starting value will be n equals 1. And then we try to show what's called the inductive step. If P of n is true, we try to show that it will follow that P of n plus 1 must also be true. And if we've shown that P is true at some starting value, and then any time that P of n is true, P of n plus 1 also has to be true, then we've proved P of n is true for all natural numbers. So here's a summary. If we can show the anchor step that P of n is true for some starting value, n equals capital N, and here capital N is 1, and we can show the inductive step that if we assume P of n is true, it follows that P of n plus 1 has to be true, then by induction we've shown that P of n is true for all n greater than capital N. So let's do that for this example. So we've let P of n be the statement that the sum of the first n natural numbers is a half of n times n plus 1. And we're going to prove by induction that P of n is true for all n is greater than or equal to 1. The first thing to do is prove the anchor step. So here we want to show that P of 1 is true. So at the moment we don't know that, so I've put a question mark there. To show that P of 1 is true, we just need the sum of the first 1 natural numbers, and that's just 1. And then our claim is that that should be a half times 1 times 1 plus 1. And we have to work out whether that's true or not. Well, a half of 1 times 1 plus 1 is a half of 1 times 2, and that is 1. So the anchor step is true. P of 1 is true. Now let's go to proving the inductive step. If we assume that P of n is true, in other words, the sum of the first n natural numbers is a half n plus 1, we're going to try to show that it has to follow that P of n plus 1 is true. So we're going to write down one side of the mathematical expression in P of n plus 1 and show that it equals the other side. So that's the left-hand side of the mathematical equation in P of n plus 1. And if we look at the first n terms here, we can use the fact that we are assuming P of n is true to write that more simply. Because we're assuming P of n is true, that sum there has to be a half n, n plus 1. And now we can write the sum of the first n plus 1 natural numbers more simply because we can see there's a common factor of n plus 1 in both of these expressions. So this is n plus 1 times something, and we get a factor of a half n from the first term and 1 from the second. And if we take out the factor of a half, and just rearrange that a little, we can see that we've shown that P of n plus 1 is true. So we've shown the inductive step. So let's summarize what we've done. We've shown the anchor step. We've shown that P of n is true for n equals 1. We've also shown the inductive step. We've shown that if P of n is true, then it follows that P of n plus 1 is also true. And because we've shown the anchor step and the inductive step, then by induction we've shown that P of n is true for all n greater than or equal to 1. In other words, we've shown that the sum of the first n natural numbers is a half n, n plus 1 for n greater than or equal to 1. So this has been an example of a proof by induction using what's called simple induction. And any proof by simple induction works using exactly the same steps. The details may be different, but the steps are the same.